Okay, so today's notes are going to be on compound interest. Now we're going to go over the definition of simple interest here first, and then we'll get into compound interest. So simple interest you learned back in 7th grade, I believe, and that means it's the interest is calculated using only the principal amount. Okay, and this is done per year. And to find the interest, you would use the principal times the rate times the number of years. Now, to find the actual balance involved with this, you would need to add that interest back to the principal. So you would say the principal plus the interest would give you the total balance or the accumulated amount. So this can be written as this equation. So you can add that, you plug in the PRT into the I, plug all of that in there. And since you have a P in both, you can simplify this into P times 1 plus R times T. Okay, so you can simplify it that way also. So any one of those three would work with finding the absolute or the total amount. Now, compound interest is found by interest is calculated on the principal amount and any accumulated interest. So what happens here is that, say, throughout the year, you earn interest each month. So that first month, you'd have, say, you start with $15, you earn a certain amount of interest. Well, then the next month, you would take that 15 plus I and earn a different amount of interest. And then that next month you would take that and then you would earn a different amount of interest and add it to it. So you're not only earning based on the principal amount, but any interest that has already been accumulated throughout the year. Okay, so that's what we're going to be looking at today and working on some more tomorrow. So the first thing you want to look at, though, is the formula for the compound interest. So on our compound interest, it looks very similar to our exponential growth function, but we have this value of n inside there. That's where the compounding comes in. Okay, so A is the amount accumulated. It's that total amount. The P stands for the principal. Okay, that's the amount you start with, or what we've been calling the initial value. And then you have your interest rate, just like we did before. And remember, that has to be written as a decimal. Now, if you've forgotten, you're going to take your percentage and you're going to divide it by 100%, which moves 2 spaces left. and that's going to give you the decimal. Okay, N stands for the number of compoundings per year. So in other words, how many times do we put the interest in during the full year that you have your rate? Okay, and then T is the number of years. Okay, so you're going to need some words to describe the compounding. And so we have some words here in these sentences that you need to remember. So we've got annually, semi-annually, quarterly, and monthly. Okay, so these are different values or times of compounding. Okay, so if something is compounded compounded annually, that means that it occurs once a year. So we compound one time per year. If it's semi-annually, that's every 6 months, so that would be compounded twice a year. And then quarterly is every 3 months, every quarter. So we cut it into 4 equal time frames, so that would be 4 times per year. And then, of course, monthly, since there's 12 months in a year, and if we compound each of those months, we're compounding 12 times per year. Now, one that they don't put on here is daily, and it is used in some of your problems, so you want to make sure daily. That would be 365 times per year. Okay, so it's not in our list there, but we want to add it on there. Okay, so let's look at a problem, and let's see how we're doing with the compounding. Okay, so in this case, we have our $1,800 invested at 7% for 6 years. So the 1,800 stands for our principal amount, that's the P. It's invested at a rate of 7%, so our R in decimal form would be 0.07, and then 6 is our time. So we have the principal, the rate, and the time. We just need the number of compounds. So when we're compounding, we look at what it's asking us to do, and it says annually. So annually stands for one time per year. So looking at our formula, okay, we're going to fill in. So our principal amount is 1,800. The 1 plus is always there, just like we did in the exponentials. Our rate is 0.07 in decimal form. We divide that by the 1, since we're compounding once a year. And then we have 1 times 6 for our number of years. Okay, now in this, when you simplify, since you are dividing and multiplying by 1, this can be simplified down to that basic exponential growth problem we had, because dividing by 1 would leave you with just 0.07, and then 1 times 6 is just 6. So this would give us the same equation that we had worked with on the previous lessons. So we type this in the calculator, go ahead and do that, and then pause for a second, and then come back and you'll see the answer. Okay, now remember, since we're talking money, we always round to 2 decimal places, so it's 0.31, 31 cents. Now the second one, if you'll notice, has the exact same principal, interest, and rate, or time. So it has the same principal, the same rate, and the same number of years, but it's asking us to compound quarterly. So in this case, it's going to be compounded 4 times per year. So we're going to substitute again into the formula, and I'm going to write the expression for the formula. And you may want to keep doing this until you kind of have it down. Okay, n times t. Okay, so we're going to put 1800 in again. We're going to still have the 1 plus. We still have the 0.07, but this time, instead of being divided by 1, it's being divided by 4, and then raised to the 4 times 6. Now, since we don't want to round, and sometimes these are nice numbers, like these aren't too bad on decimals, but sometimes you get some really ugly decimals in here. So it's always best for this part of the problem to not round or don't simplify. Just leave it the way it is. Leave the fraction in there, leave the plus sign with the 1. Don't solve any of that down to anything smaller, because if you get tempted to round while we're calculating, you're going to throw off your answer. Okay, now it's okay if you want to simplify here, because that's just a basic multiplication. So you can simplify this, because your calculator actually works better if you don't have a multiplication and an exponent. So we do want to simplify the exponent. So as we write out the simplified form, and that's to the 24th power. Okay, again, so calculate that, double check your numbers as you put it in, and pause, and then you can come back and find the answer. Now, on this, we have a 0.60. Now, when you got your calculator, you would have had 0.597, etc. Okay, so we want to remember that when we have a 9 here where we need to round to, the number behind it is very important. So this number goes up, so that means we're going to be adding 1 to that 9. And when you add 1 to 9, you get 10, which means you carry that 1 over. So 5 plus that 1 gives us the 6, and that's what gives us the 60 cents on the end when we round. Okay, so just to remind you on rounding what that means. Okay, now if you look at the two numbers that we've gotten so far, for annually we got $2,701.31. For quarterly, we got $2,729.60. So we got a lot more, not a great amount, but we got more with the quarterly than we did with the annually. So the compounding, it looks like the more you compound during the year, the more money you make during the year. So that's something you want to look for when you're going into investments. Okay, so let's look at this last one. And it says, again, same basic information at the start. The principal, the rate, and the time. But this time our compounding is done semi-annually. So that's 2 times a year. Okay, so again, write the expression here so as you're looking along, we don't have to go back up and look at it. Make sure my N looks like an N and not an R. Okay, so again, we're going to put 1800 for our principal, 1 plus 0.07 for our rate. This time we're dividing by 2 for semi-annually, and we have 2 times 6 for the number of years and the compounding. Okay, so again, you can simplify the exponent, but don't simplify the inside the parentheses, sorry. So that's going to be to the 12th power. Pause again, do your own calculation, then come back and check. Okay, and you can see again that the value semi-annually is less than quarterly. Quarterly was more compounding, so it should be larger than the semi-annually. Okay, but this is more than the annually because it's 2 instead of 1. Okay, so that's your notes for today, and then you had a handout that had some problems on it. Make sure that when you're talking about the why you want to go with something quarterly instead of annually, Talk about the fact that you're adding interest, more interest every um, 3 months instead of just once a year.